because the problem was on my side. I don't know what is happening. They say antivirus, what. Definitely it affected this. Then I will try to fix it. Now, today, in fact, initially, we planned to cover from learning unit number 5 up to the end today. But then when I was preparing this, I realized that it's going to be too much. So that is why even this split, we will have one today, and then from there have another one on Saturday. Obviously, Dr. Tamini will communicate further with that regard. Therefore, today we will look at what? Learning Unit 5, Learning Unit 6, that is from the book, Learning Unit 7, Learning Unit 8, that is up to areas. Then from there, the remaining one, that is the volumes and linear algebra, it will be covered in the next session. And now, when I'm checking here, it's already 2 o'clock. So therefore, we will push and try to finish everything, even if we go up to 6 o'clock. And again, please feel free, né? Mathematics, if you are stuck in mathematics, you are stuck. Somebody must help you at that moment. So if you are stuck, please feel free. And then from there, you can just unmute yourself. Then from there, ask me a question or raise a hand and ask a question. Then I will be happy to clear it. Okay, let us start it. Learning unit number 5. But remember this, dear student, with integration, everything starts with the general power rule. That is, if you are given something, integrate whatever. First, check whether it is not the general power rule. So let me just rewrite it here. So the general power rule, remember, is something like this. You have got the derivative of f, and you have something f here. This, it must be the exact derivative of this. Or this differ with the derivative of this by a constant factor. In other words, the actual derivative of this with what is supposed to be here, they are what? Like terms. If they are polynomials. What I'm trying to say is what? Okay, let me just finish it. Then you have got n here, then you have got a dx. There are 3 here. You must be able to tell us or be able to identify what is n. Not literally write it, but be able to aware that here, my n is this. And because it's an exponent, therefore it has got a base. And this base is your f, as we all know. And this f, it can be any function. That is why this is called the general power rule. Because f can be any function. It can be a polynomial like x squared plus 4x. It can be a trigonometric function like sine x or whatever. It can be an exponential function. It can be a log function. But once you say this is my f, then you must immediately differentiate it and compare that actual derivative with this. Okay, let us just use an example. Say you have got something like this. Say x squared plus 3, x all exponent 4 or whatever. And then here you have got what? Say 2x plus 3. That is dx. And here we can see that it matches this, the standard. Your n is 4. You don't have to write it, you just have to be aware. And then your f of x, because this is an exponent, therefore it has got a base. That base, it must be your f. So our f, therefore, is x squared plus 3x. Now we have said, we're saying Once you say this is s, you must immediately differentiate it. And what is the derivative? Is 2x plus 3. Then compare this with the untouched, the unspoken one, because we spoke about 4. We spoke about this, which we differentiated. Then you compare the actual derivative with what is here. If they are exactly the same, therefore, by this rule, the answer we know. By this rule, the answer will be what? What is your f, which is x squared plus 3x, which is x squared plus 3x. Then it will be exponent what? Now, depending on n, we know if n is -1, then the answer is going to be linear of this. Otherwise, the answer is going to be, you take your function, then you say exponent n plus 1. N here is 4. Therefore, that will be 5 divided by what? Divided by 5. Then you say plus c. Don't forget to include the c. What I'm trying to say is what? Always check whether that integral is not standard. That is, that integral cannot be solved using the general power rule. If it doesn't, then you just have to what? Now that is where the other techniques will come in. Hopefully that is clear. Now, today, we are going to look at this now. That is, looking at techniques where the general power rule doesn't work. Now, those techniques or those rules, they are as follows. Let me just read them. Surely because of time, you know them. Okay, let me just write one then. It will be this. It will be this. And this is, according to this, is rule number 25 in your book or in your textbook, which obviously will be provided with. That you'll be provided with the formula. That is number 25. Okay, say this. You have got what here? Whatever. Say 2 here over 4, say plus x squared dx. The question now is, will this rule work here? Will it work? The answer is yes, it will work. But the general power rule cannot work. The general power rule, it can work. This one can work. This one, it can work. Why can it work? Because even if you write it like this, then it will be 2 what? 4 plus x squared exponent minus 1 dx. I'm trying to show why this rule cannot work here. Because with this rule, your n is going to be minus 1. And it seems like you are going somewhere. If you compare this and this, your n is going to be minus 1. Looks like we are going somewhere. And what is your f? Your f is then what is inside the brackets, which is 4 plus x squared. Then you have to differentiate it. The derivative, it gives you 2x. Then you must now compare 2x and 2. Then you see that they are not comparable. They don't differ by a constant factor. In other words, they are not like terms. Therefore, this rule cannot work here. You need at least, if there was x here, if there was x here, if there was x here, then it will work. Because we are not going to compare 2x and 1 multiplied by x. We are not going to compare 2x, which is the actual derivative of this, and 1x. And you can see that, oh, they are like terms. That is, their only difference is the constant factor. This is 2 multiplied by, this is 1 multiplied by. Therefore, we can write 1 using 2. Instead of 1, we can write 2 over 2. And now from there, after split 2 over 2, write 2 over 2 as half, multiply by 2, and take the half outside. So, but now, If this one is a constant, like 3, or like 4, or like 3, say 2, let us put it 2 back. They differ by a variable x. This is x, and there is no x here. Therefore, this rule here cannot work. Now the question is, which rule will work? It is definitely what? It is definitely this. Why? Because now you are now going to say, okay, what is my a squared? Your a squared is 4. And according to number 25, we know number 25. 4 here is not a. 4 is a squared. And what is our f? Our f is no longer the whole denominator. F is no longer the whole denominator. F is this one, but it's now f squared. So our f now here, okay, let me just write everything. A squared is 4, and x squared is f of x all squared. Therefore, f is the square root of this. Therefore, f is x. F is x. Now, then we need what? The derivative of this x here, which is 1. And 1 and 2 are like terms. So therefore, because now we need 1 and not 2, then you take the 2 outside. Then you write 1. 1, which is the actual derivative of your f. Then from there, what is the answer now? The answer it will be now be given using the right side of this number 25. Hopefully that makes sense. And the right side of number 25, it says what? It is 1 over a arctan f of x, which is x divided by a which is 2. That is, the right side here is 1 over a, you know, number 25. That is arctan f of x over a plus c. Then you write it there. Then you use this to answer this now. But don't forget the 2 that is outside. Therefore, the answer here it will be this 2, because we are going to replace only this part, not the 2 that is outside. We are going to replace only this part. Therefore, it will be this 2, then multiplied by what? Then you use this. Then it will be now be what? It will be 1 over a. What is a? This, don't forget, this is not a, this is a squared. Therefore, it will be by 2, because if it is a squared, therefore a is 2. Then it will be now be arctan f of x. And what is f of x? Is x divided by what? Divided by a, according to this. Divided by a, which is 2, then you say plus c. Hopefully, this makes sense. And another formula now, before, let us not go far, another formula now. This, it can as well be something like this. Okay. Let us look at another one. Or, don't forget that the f here, in our earlier example, it was just a monomial x. The f can as well be what? A binomial. Say 4 plus, where here say x plus 3, all squared dx. And then from there here, write, say anything, say 7. You can see that the general power rule will not work, because with the general power rule, the f, it will be the whole denominator. The f, it will be the whole denominator. And the whole denominator is a binomial, is what? Is quadratic, because it's x plus 3 all squared, which will be quadratic, which will be x squared plus 6x plus 9 plus 4, which is x squared plus 6x plus 13. Then it is something like this: x squared plus 6x plus 13 dx. The general power rule will not work. because your f of x is this. Then what do you do now? Then you can see that, oh, here it will be exactly this one. Obviously, this, it will no longer be the answer. Obviously, it will be this one. Your f of x is this now. And you differentiate it. What is the derivative of x plus 3? It's 1. Then you take the 7 outside. Then here is 1. Then this is still your a squared, not a, but a squared. Therefore, the answer here is going to be this 7, which is outside, multiplied by, according to this, it will be 1 over a. A here is 2. Then arc tan what? F of x. What is f of x? Is x plus 3. Then divide by what? Divide by a. A here is 2. Then plus what? Plus c. That will be the answer. Hopefully, it makes sense. Now, this one, before even going far, this one is in standard form. Why? Because already we can see what is a squared, we can see what is f, because it is f of x all squared. Because sometimes they can give you this as what? As x squared plus, let us just say 6x, say plus 7. No, plus 7. Let's say plus 5, something like this. Plus 5, something like this. You have to see that, oh, the general power rule here cannot work. And what will work now? Depending on this now, depending on this, it will either be this, or it will be by what? Partial fractions. It will be partial fractions if this is factorizable. X squared plus 6x plus 5. Is it factorizable? Yes, because it will be x plus 5 multiplied by x plus 3. In other words, we are now going to write this 1 over this. Then from there, we will just solve it by partial fractions, which you did. But if this is not factorizable, then the only way out, maybe it will be this or another one similar to this. Say, change here so that this is not factorizable. Say this is 4. Then you can see that, no, the denominator is not factorizable. Therefore, maybe it will be this one, or maybe it will be this one. It will be this one. Or maybe this one. You see, it will either be this one or this one or this one. Why? Because there is no square root. Therefore, it will either be this one or this one. But after you have checked whether the general power rule will not work, and after you have checked whether this is not factorizable, hopefully that makes sense. Okay, let's see. Where do you start now? Try to write this as either the sum of 2 perfect squares. If you write it as the sum of 2 perfect squares, then it will be this, because it's squared plus squared. Or what? As the difference of 2 perfect squares. Maybe it will be a squared minus this, or it will be this f minus this one. It will depend. So therefore, all what you need to do is what? Try to complete the square here. Then it will be x squared plus 6x. How do you complete the square? Then we are now going to say plus what? Half by what? By what? By the numerical coefficient of x. Here it would now be what? 6, the numerical coefficient of x. Then you square it. And because it was not there, therefore you must cancel it. How do you cancel it? By subtracting it. We know when you add and subtract, you won't change anything. So it will now be minus what? The same thing. Then from there, plus the 4. plus the 4. And then we know if you do this, then the first 3 is now a perfect square. But make sure first that this one, the numerical coefficient here itself is a square. If it's not a square, then we make it a square first. So the first 3, it can be written as this squared. The first 3 terms. It will now be the square root of this. That is why we're saying make sure that this is a square. Because if it is not a square, then it will be the square root of something that is not a square. Therefore, then the square root of this is this. And what about this one? It will now be, it will be 3. If you can see, it will be 3. Then it will be plus 3, because it's half of 6. It's 3. Then this one is minus 3 squared, which is minus 9 plus 4. And what is minus 9 plus 4 is minus 5. Then this is minus 5. Therefore, this now, you must now see it as what? As 1 over. Then this is this. X squared plus 6x plus 4 is exactly this. And instead of writing this, we're not going to write this. And therefore, the rule now that will be applicable is this one. Instead of this, we are now going to write x plus 3 all squared minus 5 dx. You are a now. Don't forget, 5 here is not a. 5 is a squared. 5 is a squared. It's not a. And your f is no longer x squared plus 6x plus 4. Your f is no longer the whole denominator, but your f is this one. Now the big question is, do we have the derivative of this one here? The answer is what? Yes. Therefore, what is this? Because this matches this one. Therefore, the answer for this, it will be given using this one, which I'm not sure which number is it. Which number is it? Let me just check. I've written it here. Which number is it? That is f squared minus a squared. This one is number 29. Then you use number 29. Number 29, which says minus 1 over a arc cot hyperbolic f over a plus c. That is, let us just write it. It will be number 29. And according to number 29, the answer it will be how much here? The answer it will be how much? Let me just check here. The answer it will be minus 1 over a. And what is a? It will be the square root of 5. Arc cot hyperbolic f. And what is your f? It's no longer x squared plus 4x plus how much? It's x plus 3 over what? Over a. What is a? Is the square root of 5. Then plus what? Plus c. Then it will be this. Hopefully, this makes sense. Now, if you understand this, then surely you should be able to understand what? The one that is called the SAT. Because the approach is the same. Here, they can say the square root. Then it's no longer, you see, but the approach, it will still be the same. Here, they can still say what? The square root.
Hello, Minir.
Yes, yes.
I just want to ask.
Yes, yes, ask.
The question you were dealing with, I just want to ask something. When we are now writing the answer, are we supposed to write the square root of 5 when we are saying 1 over a, or we are supposed to just write 1 over 5 without the square root?
No, the answer for this, remember we are using which rule? That is rule number, I'm not sure it's rule number 25. Yes, it's rule number 29.
It's a rule number 29.
29, eh? It says minus 1 over a, not minus 1 over a squared. So 5 here is not a, but it's a squared. 5 is a squared, not a. Like what we said about 4 somewhere, I can't remember where we've said 4 is not a, but is a squared. Because we are using this rule. We were using this rule without, the only difference is what? One has got the square root and one doesn't have the square root. This is a squared. That is, we have said something like this. What 1 over what? Whatever. Say what? 4 plus x squared dx. This 4 is not a. It's a squared. Therefore, if you answer this, then it must be 1 over. It cannot be 1 over 4. It will be 1 over the square root of 4. The square root, because if this is a squared, therefore a is the square root of 4, which is 2. The same story here. 5 is a squared. Therefore, what is a? Therefore, a is how much? Is the square root of 5. That is why here our answer was 1 over this minus 1 over the square root of 5. Arc called hyperbolic. F, it was x plus 3 over a. A is not 5, but is the square root of 5, then plus c.
Yeah, noted, sir.
And once you understand it, as we have said, what? Then, because what the same principle, once you understand the one without a square root, then you should be able to understand what? The one with the square root. The only difference is this one, it will be maybe be number 29, and the one with the square root, maybe it will be another one, maybe number 27 or whatever. I'm not familiar with their names or whatever. So the same story, the same story, the same story. Let's say you have something like this, whatever. Let me just think. Say 4 over what? Say whatever. Say 3 minus 2x, whatever, minus x squared. No. Let's make sure that is not factorizable. Say something like this. They say integrate this. Whether it has got a square root or no square root, the principle will be the same. What I'm trying to say is, whether you are answering this or you are answering this one, the one that has got the square root, the principle is going to be the same. The only difference, it will be in the final answer now. Because this one, maybe it will use number 27, because it is without a square root. And this one, maybe use now another one, maybe number 28. But the approach, it will be the same. Then what is that approach? The approach, it will be what now? Because this is not factorizable. 5 minus 2x minus x squared is not factorizable, meaning we can't use partial fractions. Therefore, you will try to write this as either the sum of 2 perfect squares or the difference of 2 perfect squares. And with the difference of 2 perfect squares, it will either be a squared minus f all squared or f all squared minus a squared. It will depend. Let's see. Say, with me, I prefer writing it as in descending order. I would prefer to start with this minus x squared, then minus 2x, then say plus 5. With me, I prefer writing it like this. But I saw in your book, they use another approach, which is no problem. Then from there, I will make sure that this one is a square. And minus 1 is not a square. Therefore, we'll take it out. Then I will say minus, then what then? Whether inside the brackets, no. Whether inside the sat sign or whether outside, the approach is the same. Then it will be x squared plus 2x minus 5. It will be this. Then from there, I will say minus, then I will complete the square here. The usual way of completing a square. If it was minus 2 here, I will take the minus 2 outside. So then it will now be x squared plus 2x. And then from there, I will then add what? Because I'm now completing the square. It will now be what? Plus what now? Half of the numerical coefficient of x, which is 2. It will now be 2 here squared minus what? Half here, 2 squared minus what? Minus 5. It will be this. Knowing very well that these two, they cancel each other. Then from there, we know very well that then, where's another color? Where's blue? Where is blue? No, I can't see blue. I can't find blue. Let me just continue. Let us just continue. It will now be minus what then? This first three terms, we know it. These first three terms, it will now be the square root of this, which is x. And what is this? It's half of 2, which is 1. Then it will be plus 1 squared. Then from there, you will then add these 2 now. It will be minus 1 minus 5, which is minus 6. Then is this. Then from there, you remove brackets. And when you remove brackets, then this becomes 6 minus this. It becomes 6 minus x plus 1 all squared. Then is this. Then you then rewrite this. The denominator as 6 minus in brackets it is. 6 minus in brackets it is 5 minus 2x minus x squared, but written as what? The difference of 2 squares. In other words, we have completed a square. So which will then be 1 over, you write 6 minus x plus 1, then squared dx. And don't forget, 6 is not a. 6 is a squared. 6 is a squared. And then from there, it will be which rule now? Because it will be a squared minus, what is important before going far? This is now our f. X plus 1 is now our f. And do we have the derivative of x plus 1 here? Yes. Whether it was 4 or what? If it was 7, then you take the 7 out. If here it was whatever, 6, then you take the 6 out. Here we have said 4, then we are going to take the 4 out. 4 is out. Therefore, the answer here will be this 4 multiplied by the answer for this, depending on which rule. So which rule? It will be rule number what? Number 28. I've just written the rule here just for reference sake. It will be number 28, which is the derivative over a squared it is, which is now 1 over a. That is number 28. 1 over a, what is a? A is the square root of 6. You see, a is the square root of 6. What? Arc tan hyperbolic. That is arc tan hyperbolic. What is f? X plus 1 over what is a? The square root of 6. And don't forget what? Don't forget the c. The same story with this. You just have to take this and complete the square and write it like this. And this one with the square root. Which one is it? The one with the square root. Because now this becomes integral of 4 over, now it will not be the square root of 6 minus x plus 1 all squared dx. Then this, it becomes this. You take the 4 out, then the answer will be 4 by the answer for this, which is no longer number 28, but which one? Number 24. Hopefully you have this. It will be number 24, which is arc sine. which will now be, there's no 1 over a. With number 4, it will just be what? Number, that is this 4. Then it will be arc sine f. What is f? X plus 1 over what? What is a? Is the square root of 6 plus 6. Then this, it will be the only correct answer. Anything else, it will be 0. But as we are saying, what is important is what? Be able to identify that this cannot be solved using the general power rule. There from there, if they denote, I mean, if there is no square root, because if there is a square root, then obviously then you can't solve it with partial fractions. But still there, check whether you cannot, the square root cannot be cleared. Because if there is a square root, it doesn't mean that, obviously, it doesn't necessarily mean that it will now be either number, the ones with the square root. If the square root cannot be cleared, it doesn't mean that this, it will be 1 with square root. That is, 1 with square root is number 26, number 24, and number 27. No. Why? Because you can still have something like this. You can still have something like this. 1 over, say, whatever, say, x squared plus 6x plus 9. That's something like this. Are you going to say because it's the square root? Therefore, it will be one of those three. That is either number 26, the square root of a squared plus f of x all squared, or number 24, which is a squared minus f of x all squared, or number 27, which is f of x minus a squared. Not necessarily. You first have to check. Can we create the square root here? That is, the question is, can we write this as a square? Try to factorize it first. You can see that, oh, this is a square. X squared plus 6x plus 9 is x plus 3 multiplied by x plus 3. Therefore, then this becomes 1 over the square root of x plus 3 all squared, which is this. And the square root of, and the square will cancel each other. Therefore, this is just 1 over x plus 3 dx, which is simply ln of f of x, which will be ln of this. Which will be ln of this. But if you don't see it, then it becomes a problem. Check first. Hopefully that makes sense. And what is nice about this is what? Once you understand this, that is the one with a fraction, f, the derivative divided by either a squared plus f of x squared, or the derivative divided by f of x squared minus, or the derivative divided by with the square root. Once you understand them, then the next unit, which one is it? Unit 7. It will still be very simple because it follows the same approach. It's the same concept. That is, or before going to unit 7. Any question on this? Because this is all about unit 5. It has got how many rules? 6 rules. That is 25. That is 24 up to 29. 24, 25, 26, 27, 28, 29. But as I've said, before you think about those, check whether this cannot be solved using the general power rule. Check whether this cannot be solved using partial. Partial will only work if there is no square root and the denominator is factorizable. But still, if there's a square root, first check whether that thing that is inside the square root cannot be written as a square. If it can be written as a square, then it will be the square root of a square. And the square root of a square, then the 2 of the square and the 2 of a half, they will cancel each other. Then you now have what? a nice fraction that can either be solved using what? Partial or whatever. Hopefully that makes sense. Any question before we proceed to, I thought, let us take this way. Let us say from unit 5, let's jump unit 6 and go to unit 7. Why? As I've said, the approach is the same. Any question on that? If no question, look at it. Look at it. Or compare these two. Compare these two rules. Compare these two rules. You have got one rule here that says this. That says this. Not sure which rule is this, but it will be one from unit 5. And there is another rule in unit 7 that says this. Unit 7. There is a rule in unit 5 that says this. That is, it's a fraction. It's something divided by this. And there's another rule in unit 7 that says instead of this divided by this, is now this multiplied by this. The same story. There is a rule in unit 5 that says this. This is what? That says this. And there's an equivalent rule in unit 7 that says this. Instead of a fraction, now is given as a product. Instead of divide by, is now this. The approach is the same. The approach is the same. The approach is the same. Okay, we cannot talk about it this one. The one without the square root. We cannot talk about it this one. We can't talk about it this one. Can't talk about it this one. That is, you cannot talk about it this one. Say the integral of x plus 3 multiplied by what? Say x squared plus 4x plus whatever this. Why? Because here you can just remove the brackets. Remove the brackets and integrate a nice polynomial. The question then becomes what? If there is a such sign, it is. You can no longer, that technique of remove the brackets will no longer work. Will no longer work. That technique of removing brackets, it will no longer work. You see. And that is what we're going to talk about. That is why this is not even listed here. So what do you do now with this now? This. No, this, it must be what? This rules. This is, then the other rule, it will be what here? Because this is a squared minus, this is f squared minus, then here it will be a squared plus f of x. Like that is unit 7. It's either this or this or this. The approach is the same. Hopefully this makes sense. Hopefully this makes sense. This one of a squared plus is number 31. This is number 31. This is number 31. This one of a squared minus is number 30. This one in your book is number 32. It will now depend on how is it, good. Okay, say this. Let us not go far. Let us not go far. Say you have got something like this. Or even before this, say you have got this. Even before this. Even before Unit 7. This is Unit 7. What will be the answer here? Anybody? What will be the answer here? Or what will be the rule at least? And this is standard. Do you have anybody who want to try it? The answer? You can't say a squared is 4 and f is x exponent 4. Is x is a squared? That is, is it this? Is it this one? Is it this one? The answer is what? Yes, it's this one. We just have to manipulate it a bit. This one is f squared. Meaning, see this as that is f is x squared. Now, what is the derivative of x squared? It's 2x. Therefore, you are just going to insert 2 here and cancel it by writing half outside. Therefore, the answer will be this half that is outside. 1 over a arctan f is x squared divided by 2. Hopefully that makes sense. Hopefully that makes sense. But still on this, what if, but please stop me. What if is something like this? What if you have got something like this? Will it still be this one? The answer is a big no. It's not this one. The answer is a big no. So what is the answer? You can see that if you take f as the whole denominator, that is f now, you are no longer going to say, you can't use this one. Because with this one, this is not f, it's f squared. With this, f is not the whole denominator, but it will be x squared. And 4 is a squared. But now, if you have got x cubed here, therefore, f is the whole denominator. F is the whole denominator. Which is derivative now is 4x cubed. Then you compare this and this. It will depend. You compare this and this. Then you can see that, oh, they only differ by the constant factor 3, because this is 1 multiplied by x cubed and this is 4 multiplied by x cubed. Therefore, their only difference is this is 1 multiplied by, this is 4 multiplied by 1 multiplied by x cubed, and this one, they are like terms. You can multiply 1 by a constant factor and get the other one. And because they differ by a constant factor, then you can just simply introduce that constant factor and cancel it by writing its reciprocal outside. Hopefully that makes sense. Now, if all is fine, then let us go to learning unit 7. Why? Because both of them, at some point, you have to complete a square. That is why I have chosen the sequence. That is why I have chosen the sequence to say from learning 5, let us go to learning 6. No, learning 5 to learning 7. Say something like this. Integral of what? Say x, just say x here, the square root of say x plus 2. Something like this. Okay, let us start with this one before this. Let us start with this one before this one. We will come back to this one. Let us start with this one. Or before, because this one it can still be solved using what? Integration by parts. So let us stick with the one that will strictly follow this one. Say x here, say plus 3, something here. Something like this. Say x plus whatever, say x plus 1 or 2x, say 2x, say plus 2. That's right. Let us start with something like this and then build on this one. If you understand this one, then we can then go up a little bit. Now, can we use the general power rule? Can we use this one here? Can we use this one? Maybe you try, but with experience, you should see that, no, this one, it will never be this one. It can't. Why? Because your n here is going to be a half. Then your function is going to be x squared plus x plus 3. Then you immediately differentiate this. If you immediately differentiate this, you get this. Then you can see that this one is not the same as this one. And you cannot multiply 1. Multiply either this one or this one by a constant factor and get the other one. Hopefully that makes sense. You cannot multiply this maybe by 2 or by half or by any real number and get this one. Or multiply this by any real number and get this one. Therefore, the general power rule here is out. This is out. This is out. So which one is in? It will either be this one or this one or this one. It will either be this one or this one or this one. So let's try it now. Let's try. Now with this one, whether it's this one or this one or this one, the approach is the same. The approach is the same. Then what do you do? Hopefully we're together. Then you say, oh, my f is this, which its actual derivative is this. Actual derivative is this. So whether we are going to use this one or this one or this one, then we need what? This actual derivative here. Whether you use this one or this one or this one, whether this at the end will meet this one or this one or this one. Therefore, here we need the actual derivative, 2x plus 1. Then what do you do? Then you write this one using this that we need. Let us pause it a bit. We're saying what? We need the, we write this using the actual derivative. I've been going up and down now. It says here my battery is low. Let me just, good. Is it okay? No, still not okay. Then it means I swapped the charger during that up and down. Okay, now it's okay now. My laptop is charging, it won't go out of battery now. Okay, are we together? Does it make sense? If yes, then we start. Then we say.
Can you repeat, sir?
Remember, Here the general power rule failed. Most importantly is what? We cannot remove the square. No, we cannot remove the square root. If maybe this x squared plus x plus 3 can be written as a square of something, then that's it. We are done. That is, if you have something like this, say 2x plus 2 by the square root of x squared plus 2x plus 1, then we are done. Why? Because this one can be written as a square. Then it will be the square root of the square. Therefore, the two will cancel each other. Because this one we know it will now be 2x plus 2. This is the square root of x plus 1 all squared dx. Then the square root of this is gone. Then you just multiply it. And then you get a nice polynomial. Then you integrate that nice polynomial 10 by 10. Hopefully that is clear. But now, with this one, how are we going to remove the square root? We can't. Why? Because this one cannot be written as a square, meaning it can either be written as the sum of two perfect squares or what? The difference of two perfect squares. We are going to try and rewrite x squared plus x plus 3 as a squared minus f squared or what? Whatever. A squared plus f squared or f squared minus a squared or a squared minus f squared, which will be one of these three. But now where do you start? Where do you start? You say, okay, let this one be f. This one be f. This is f. You say, let it be f. For now. Then you say, what is its actual derivative? Say, if I have to use the general power rule, if I have to use the general power rule, if I have to use the general power rule, if I have to use the general power rule, n is going to be half, n is going to be half, n is going to be half. And what is our function? Is the base of that n, which is going to be x squared plus x plus 3. Hopefully we are clear. Now from there, you differentiate f. Because according to this, you must have the derivative here as one of the factors of the integrand. And the actual derivative of this is this one, which we need here according to this. And this, they are of the same degree. They are of the same degree. Then what do you do? Then you write what is here using what we need. Hopefully that makes sense. So that it will either be f and its derivative, f and its derivative, f and its derivative. Remember, with learning unit 5, it was a fraction. This divided by this, this divided by this, this divided by this. Now it's no longer this divided by this, it's now this multiplied by this. Hopefully that makes sense. But now, with this one of product, what do? You say, okay, my n is this, my f is this, which its actual derivative is this one. Then you write 2x plus 2 using 2x plus 1. There is no equal to here. Then we want to write equal to here. Hopefully that makes sense. Let us go through this again. You write what is here using what we need according to that thing. Then you write 2x plus 2. Then we, instead of 2x plus 2, we want to write something that contains 2x plus 1. Now the question is now, what must we do to this so that it is still 2x plus 2? What must we do here? There is no equal to. Don't come and say, no, what we do on the right, we must also do it on the left. There is no equal to. So what must we do here? So that we can write equal to here. What do we do? You just add 1. Therefore, this is equal to. Therefore, this here, it can be substituted by this. And what is important is this contains this, which is this one. Does it make sense?
No, sir. Can you repeat what you did? You just did again, starting from 2x plus 2 before we go to the other one. Thank you.
Yeah. What we want is what? We want to write 2x plus 2 using something that contains the actual derivative which we need here. Because if this is f, then we need the derivative of f here. This is 2x plus 2. Then we want to replace it. We want to replace it with something that has this. We want to write this in terms of this. So this already is 2x plus 1. And I want to write equal to here. There's no equal to. Don't come and say, what we do on one side, we must also do it on the other side. Yes, I know it. People will say that. Here, I want to write equal to. Is this equal to this one? Can I write equal to now here? No, we are wrong. We can't write equal because this is not equal to. Then the question is, what must we do here? First, before we write equal to, get the sequence. We don't write equal to, thereafter add something or subtract something. We subtract it first, or we add it first. Thereafter, we write equal to. Here, we need 1, so that it can be 2x plus 2. Now, therefore, the 2 are equal to. Then we can write equal to. Hopefully, it makes sense. Say, suppose.
Yes, sir. Thank you.
Say, suppose this, it was this, the actual derivative. I'm not saying it's right. Say, suppose the actual derivative of this, it was this. Then you compare this one and this one. Are they the same? No, they are not the same. Then what do you do? Then you write 2x plus 2 using this. Another question is, how can we manipulate this so that we can write equal to? What must we do to 2x plus 3 so that it becomes 2x plus 2? Then you say minus 1. Then you write equal to. Then it means this, it can be substituted by this. It can be replaced using this. But what is important is what? This one now contains the actual derivative. And once you understand it, then you can either answer this one or this one or this one. Hopefully that makes sense. Here is 1. So therefore, here it will be now be what? 2x plus 1, which is this. But we don't need plus 1. We need plus 2. Therefore, you add 1. Therefore, you add 1. But you do it before writing equal to. Hopefully it makes sense. Now, after this, then we are now going to replace now, as we have said, we are going to replace 2x plus 2 by this. Then it will now be 2x plus 1 plus 1. This is still 2x plus 2. This is still this one. Then you multiply it by the square root of this. Then what next from here? Then you then expand. You then expand. You take this as 1 unit. It's like saying what? X plus y multiplied by what? X squared plus 4. This is the same as what? This is the same as x multiplied by x squared plus 4 plus y multiplied by x squared plus 4. We know is this. That is what we are going to do from here. Then it becomes what now? It becomes the integral of 2x plus 1 multiplied by this. Then you say dx plus 1 plus 1 multiplied by the integral of, say, x squared plus x plus 3 x, let's just say square root, then dx. After expanding, we now have 2 terms. We now have 2 terms. Then what now? Then this is the general power rule. Then this is the general power rule. Your n here is half. Your n, the first term is the general power rule. Always the first term, it will be the general power rule. This is how much? N is half. Your f of x is this. And your actual derivative of this is this. Then the first term is the general power rule. It's right. The second term, it will be 1 of this. Where you just have to complete the square here now. The first term is done. Let me just erase the original one here now. Come back in here. Finish it here. What will be the answer for the first term? The first term, as we have said, is this now, is 2x plus 1, x squared plus x plus 3, exponent half, dx plus integral of, then you complete the square here. X squared plus x plus 3. Write it as either as this. Either this one or this one or this one. Where you are going to say this is x squared plus, then it will be x plus half of. The numerical coefficient here is 1. Then it's squared minus the same thing, then plus 3. It will be this. Switch off your camera. I'm not sure who is it. Is it Maraba?
Somebody's, I did.
Yeah, somebody's camera is on. Then what do you do now? Then we are now going to replace this by this, which is how much? This now. How much is it? It will be x. Then you say, is that what? Half of 1. It will now be half all squared. And this is minus half squared. It's minus 1 over 4. This is minus half. It will now be minus 1 over 4 plus 3. And because it's 3, the denominator must be 3. Therefore, it will be 12, no, yes, 12 over 4. This is 3. Therefore, this becomes 11 over 4. Therefore, this now, hopefully we are still together. Therefore, it will now be what? The square root of, because x squared plus x plus 3 is now this. So then it will now be x plus 1 over 2 all squared plus 11 over 4 dx. Which then becomes what? Now we know the first time is the general power rule, which will then be x squared plus x plus 3 exponent 3 over 2, 2 over 3 plus, what is this now? Your f is no longer x squared plus, this is no longer f. This is no longer f. Because otherwise, if you say it's f, then we need its derivative here. This is no longer f. But we have written it as the sum of 2 perfect squares. We have written it as the sum of two perfect squares. Therefore, it will either be, because we had three of them then, it will be one of those three. It will be what? The f is now this. Your f is now this. Your f is now this. But the question now is, do you have the derivative of this here? The answer is yes, the derivative of this one is this one. Our f is what is inside the brackets. That is, now our formula now here is this one. Our formula is this one. Our formula is this one, which is number 31. Which is number 31. This is number 31. This is number 31. 11 over 4 is not a. 11 over 4 is a squared. 11 over 4 is a squared. You can just write it. Okay, just write it using this formula. 11 over 4 is a squared. And according to number 31, it will not be what? A squared. Don't confuse it with those of learning number 5. Because those with learning number 5, it was something like 1 over a, what? This one, it says a squared, meaning it will now be 11 over 4 divided by 2. Divided by 2 is the same as multiply by this. You use the whole 11 over 4 is a squared. Then this number 31 says a squared. What now? Arc sine hyperbolic, yes, sine hyperbolic f. What is f? F is x plus half, which can be written as 2x plus 1. That is 2x plus 1 over what? Over 2. This is f. And divided by what? Divided by a. So divide by a. And it's the same as what? Because a is a fraction. And divided by a fraction is the same as what? Multiply by the reciprocal of that fraction. Therefore, it will be multiplied by what now? That is 2 over the square root of 11. Remember, this one is a squared. That is why we use 11 over 4 as it is. But then this one says f of x. This is f of x. Divided by, it's not divided by a squared. It's divided by a. So it will be this. So now, close brackets. And what else now? It will now be f of x. What is f of x? F of x is this one again. That is, which is 2x plus 1 over 2. Now they say divide by 2. That is, multiply by 1 over 2. That's good. Then it will now be the square root of 11 over 4 plus 2x plus 1 over 2 all squared. Then plus c. Then from there, you just have to simplify this. You can leave your answer as 11 over 4 multiplied by 1 over 2. The answer must be 11 over 8. And then this 2 here will cancel this 2. Therefore, it will be arc sine hyperbolic 2x plus 1 over the square root of 11. The same story. Oh, this one, that's right. This is right. Yes, this is going to be 2 by 2. Then it will be 4. Then that will be the answer. Even because remember here we are saying there are 3 rows. Even if it was minus here, even if this was minus, it will be another rule. The minus may be coming from when we were completing a square here. Even if this it was 11 over 4 minus, then it will be another rule. That is, if this at the end, that is x squared plus x plus 3 at the end is how much? Say 4 minus x plus 1 all squared. You see, your f is going to be this. Then it will be another one. It will not be this one then. It will not be this one. It will not be this one. dx. It will not be this one. That is the second term. The first term, it will always be what? The general power rule. Because you have to rewrite this. You have to rewrite this. Using what? using the actual derivative of this. And thereafter split, write it as a binomial. And the first term we're saying it will always be the general power rule. The second term, it will be one of those three under learning unit 7. Because it will either be the sum of two perfect squares, or a squared minus f all squared, or f squared minus a squared. That's it. Any question? Any question thus far? Any question? Any question? And surely they are not difficult, but please don't get the approach wrong. Start with the general power rule. Will the general power rule work? If it doesn't, then it will either be what? Learning unit number 5 or learning unit number 7. But obviously check whether the square root cannot be just be replaced. Just check whether this first is not a square. Because if this is a square, then it will be the square, it will be the square root of a square. Then the two will cancel each other. The 2 of the square and the 2 of half. Then they will cancel each other. Then you are done. Then you are done. Therefore, you don't need learning unit 5. Those rules in learning unit 5. You don't need those rules in learning unit number 7. Any question? Any question before we move on? Look, even this one, I think this comes from let's say from practice. Let's say this minus 2x plus 1 over what? The square root of, let me just something here, 4 minus 3x minus x squared dx. Which one will be this one? You can see that, can this one be written as a square? Maybe as x plus 3 all squared, because if this one can be written as a square, that is if minus x squared minus 3x plus 4 can be written as like, say what? Like x squared plus 6x plus 9. This is x plus 3 all squared. Therefore, the square root of this, then this is just x plus 3. Then it will be this divided by x plus 3, which is now improper. Which will now be what? Reduce it to proper first. You see. But this one, no. Then what do? It will be the same approach. It will be the same approach. It will fall under learning unit number 7 with those 3. It cannot be that you write, you say, okay, what is f here? F here is this. That is f, as it is. And what is its actual derivative? Then you compare this one and this one. Ah! Then I must now write minus 2x plus 1 using minus 2x minus 3. Because I want to replace this with something that contains this. Then what must I do this one? What must I add here? Or what must I subtract here? So that this minus 3 becomes 1. Then you say, oh, I can add 4. That's right. Then you add 4. Then you say equal to. Then you are now going to replace this using this. But seeing this as one unit. You see. Then this becomes what? This becomes what? Then this becomes, instead of this, then we're going to write minus 2x minus 3 plus 4 all over this. And then when you split it, then it becomes this. When you split it, it becomes this. We've said plus 4, ne? It becomes this. And what is this? This is the general power rule. 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 Why? Because n here is minus half. Because now this becomes this. Exponent minus half. And this becomes what? 4, take the 4 outside. Then here, you then complete the square here. Here, you then complete the square. Then this, it will now be learning unit 5. This, when you complete the square, it will then be learning unit 5. You say minus x squared minus 3x plus 4. This is, take the minus out. Then I just need to take the minus out. Minus, this is plus, this is minus. And then from there, here, you are now going to say plus half of 3 all squared minus half of 3 all squared. And this is minus 4. Remember, we took the minus out. Then this becomes minus, in brackets, this is now x plus 3 over 2 all squared. This is minus 9 over 4. Because it's minus 3 over 2 all squared. Then it becomes minus 9 over 4 minus 4. Minus 4 is minus 16 over 4. So then this becomes minus 25 over 4. Don't forget the minus. Then when you remove the brackets, there is a minus here. When you remove the brackets, then this becomes 25 over 4 minus this. All squared. Then you then replace this. After completing the square, you have this. Then you then replace this with 25 over 4 minus what? X plus 3 over 2 all squared. Then your f is no longer this. For the first term, yes. For the first term, your f is this. Your n is minus half. And the actual derivative of this is this. Therefore, it will be the general power rule. This one, no. It will not be one of those in learning unit number 5, which says the derivative, because your f is now this. What is the actual derivative of this? It's 1. Then you have got 1 here, because you take the 4 out. Take the 4 out, write 4 here, and have the actual derivative, which is 1. Then this, don't forget, this is a squared. So I'm not sure which rule is it. Then from there, you just simply copy it and paste it. The one that is square root of a squared minus f all squared. Hopefully that makes sense. Don't forget, we've said you can stop us at any time. If something is unclear, then we can go through it as many times as possible. Good. Any question? Any question? Not this. Not this. Not this one. Or let me just try. Let me just try my luck. What about this one? What will be the answer here? Can we use the general power rule here? No, can't be the general power rule. Because your f is going to be this. Then you need minus 2x. But then this one is standard. Why? Because this one is exactly this one. I think we have already spoken about something like this. Then this one. That's right. Your f is now this. This is your a squared. F is this, the derivative is 1. So on and so forth. Good. But what about this one now? What about this one? Integral say this. You see, it's straightforward. Why? Can't say it's the general power rule. Can't remove this. Can't remove the square root. You can't remove the square root because this, it cannot be written as this. You can't write this as this. You see. Then what next now? Then you can see that this, it will be one of those three in learning unit number 7. Your f, now see this, your f is now x. Your f is this. Its derivative is 1. This is a squared. So which one is it? It will be one of those three from learning unit number 7. From learning unit number 7. Hopefully that makes sense. If everything is still okay thus far, if everything is still okay, I think we now need to move on to which one? Let me just check here. I've written them here in that order, page 1, page 2. Where is page 3? This is page 5. This is page 4. Where is page 3? Where is page 3? Oh, I think page 3, it must be integration by parts. I think it must be integration by parts because I don't have it here. Is there any question on integration by parts? Is there any question on integration by parts? Any question on integration by parts? Generally, where do we use integration by parts? Anybody? Anybody? Where do we use integration by parts? Because it starts there. You must be able to see that, oh, here the general power rule cannot work. Here this rule cannot work. The only rule that will work here is this one. Where do we use integration by parts? Okay, is this page 3 here? That's right, that's right, this integration by parts. Where do we use it? Anybody? Where do we use this technique called integration by parts? Anybody, Sitole? Chuma? Mpela? Any volunteer? Ah, nobody.
Yeah, well, yes, sir.
Yes. My question is, where do we use it? When do you use it? Because you must be able
we
to.
use it.
Yes?
I say we use it when we multiply two products that are not the differentiation of each other.
Perfect. You use it, number 1, when you are integrating what? The product of two functions which are not related by f and its derivative. If you look at all the rules that we have done thus far, if you look at all the rules that we did thus far, we will say this is f. Then from there, continue and differentiate it. And then from there, compare the actual derivative with the unspoken, because if you look at all of those, they will have 3 factors. Maybe you will have n as an exponent. Then you will have the base of that n as f. Then you will continue and differentiate this f. And the last one, it must be comparable with the actual derivative of that f. But there would be instances where what? That product, this function and this function, they are not in any way related to f and its derivative. Example, or before the example, before this example, let's say this, you have got this. Say x here, e exponent x squared this. Can we use by parts here? No, we can't.
Yes, sir.
Why? Can we use by parts here? No, we can't. Why? Because here, this one matches this. Matches this. This matches this. You see. Which is this? The answer it will be this. Why? Because our A is this. This is A. It's E. It's A. And what is F? This F is this. The question is, what is its actual derivative now? That is, what is the actual derivative of x squared? Is 2x. Is 2x. Then you now compare 2x. We're now going to compare 2x with this one. Then you can see, oh, the only difference is the constant factor. This is 2 multiplied by. This is 1 multiplied by. Therefore, here, the product is related by what? Then here you just write 1, and then you write 2 here, and then you write half outside. Therefore, the answer here, it will be according to this rule. Then it will be this half, then you replace this part. Using this. Therefore, it will be by what? E exponent x squared over what? Ln E plus C. And ln E is 1. Then we don't even write this. Divide by ln E. That's good. Hopefully that makes sense. But now the question now is, what if this is, what if you have got something like this? What if you have got something like this? You can use this. Because yes, f, you're going to say is x. But what is the actual derivative of x? It's 1. Then you are now going to compare 1 with this variable x. You cannot multiply this by constant and get x, or multiply x by constant and get 1. Unlike if it was this. The actual derivative is 2x, and this is 1. You can multiply this by half and get 1x, or you can multiply 1x by 2 and get 2x. Therefore, the only difference between this and this is this constant factor. And because it's a constant, we can always introduce. We can just write 1 as 2 over 2 and see 2 over 2 as half, multiply by 2 and take the half outside because we need 2, not half. But once you change this and write it like this, then this is out. You can no longer use this one. Then which one now is a technique called integration by parts? It's a technique called integration by parts. That is right. Or even integrating one. Say ln of x with respect to this. Or integrating any what? Inverse trigonometric functions. But not this one. Not this one. What? E exponent x by sine hyperbolic x. Not this one. Yes, they are not related by a function and its derivative, but not this one. But this one, yes. E exponent x by sine x. Yes, this one, yes. This one, yes. This one, no. This one, yes. This one, yes. Why this one, no? Can anybody tell us? Why this one, no? The product of an exponential function and a hyperbolic function. Why no? Because we can write this any hyperbolic function, whether it's sine hyperbolic or cos hyperbolic or tan hyperbolic, it has got what? An equivalent exponential form. We know this. It will be e exponent x minus e exponent x all over 2. Then instead of this, you use its equivalent exponential form. Then from there, you remove brackets. You will now be integrating what? The difference of two exponential functions, which will now be the one that we have just spoken about. But if you have this one, you've got this one, you've got this one, or integrating any inverse trigonometric function, you will have to use this technique called integration by parts. We know it. So how does it work? Surely you know it. Okay, let's start here. Let's start with this one. Integration by parts. It's like what? Somewhere in grade 2 or grade 5 or somewhere there. It's like what? It's like the case substitution. You are given something in terms of a certain variable. Here, you are given this in terms of the variable x. The integrand being this one, this product. Then you introduce another variable. Here, we're going to introduce two variables. And thereafter, what do? We manipulate those two variables. And after, we integrate. And the second, remember, this is the initial integral. This is the initial integrand. That is the given integrand. After all the substitutions and the manipulations, some way, don't think that avoiding this, you will avoid integration at all. But some way, you are still going to integrate. But that second integral, it must be simpler. Or let me just put it this way. That second integral, it mustn't be more complicated than this one. If it is now more complicated than this one, then you must know that what? Your choice of variables is wrong. You go there and what? And change those choice of variables. But now the question is, do you have that time? Will you have that time in a test, trial and error? No, you can't. Therefore, you must know right from the onset. So which one must be chosen as this and which one must be chosen as this? And there's a guideline there in your book that says, or generally, choose U as something that you can differentiate. Because from U, you must differentiate. And choose DV as something that is standard to integrate. My assumption is, yes, you know something about integration by parts. We don't have to go there. Then what do you do here now? You're going to say, let U be which one here? Because this is like x multiplied by e exponent x dx. Or you can see it as e exponent x multiplied by x dx. Because this is a product, therefore you commutative, you can swap them. You can say it's x multiplied by this, or you can say this multiplied by this, so on and so forth. The x and the e exponent x, you can just swap them. So which one between x and e exponent x? It will be our u. Now, if you have got something like this, where what? Where one factor has got a finite derivative, where one factor has a finite derivative, then you choose it as u. So let's start with e exponent x. Let us start with e exponent x. You differentiate e exponent x. Does it have a finite derivative? No, because the derivative of e exponent x is just e exponent x. You can still differentiate e exponent x again. There's no way where you are going to get a constant. There's no way. Derivative of e exponent x is still a variable, e exponent x. The derivative of e exponent x is still a variable, e exponent x. Unlike if you've got something like this. Say what? I don't know what to write. Say e exponent x sine of x. All of this, they don't have a finite derivative. The derivative of this is e exponent x. The derivative of this is e exponent x. There is no way that you will get a constant like 1 or a constant like 3 when you differentiate in this. But what about this one? The same story. The derivative of sine x is minus cos x. The derivative of minus cos x, no. The derivative of sine x is cos x. The derivative of cos x is minus sine x. The derivative of minus sine x is what? Is minus cos x. There is no way you will get a constant. Therefore, then, what do you do? Because we are saying if one factor has a finite derivative, then choose it as u. So here, then, the derivative of x is 1, and 1 is a constant. Therefore, you can just choose u as x. This is x. This is this. This is out. It's x. Now you have this part now. You have this part, which must now be chosen as what? As dv. And most importantly, this is standard. You can integrate it, is standard. So therefore, from here we know, then what here? Then from here you differentiate. Then it will be du dx is equal to 1. Therefore, du is equal to this. And this side, you then integrate from both sides. That is why we're saying generally, choose dv as something that is standard to integrate. Because once you choose dv as something, then you must then integrate it. Then it must be standard. So what is the integral of this? V we know is e exponent x. We are now going to write this, which is in terms of x, using the u's and the v's now. Hopefully we're together. Therefore, this now, it will not be what? Is the integral of this is u. And this we've said is dv. And this by integration by parts, by that formula, integration by parts, what is the answer? Is uv minus v du. Then what do you do from here? Then you then substitute back. You then go back to x. Go back to x. Then you say, what is u? It's x. Then you write it, it's x. And what is v? It's e exponent x minus, and we have said it is. You are given it is. It's a product. Then we're saying here, because we're still going to integrate, then this, it mustn't be more complicated than the one that you started with. You mustn't have x squared e exponent x here. If you have something like this, then it means your choice here is wrong. Then you go and swap. Why? Because now this is just two factors. X multiplied by e exponent x. And how many factors here? There are now 3. It's now x by e exponent x, which is now more complicated than the one that we tried to avoid. If it is of the same degree of difficulty, all what you need to do is what? Repeat it. That is, have this somewhere, then from there, repeat integration by parts here. If it is more complicated, go and change this. Good. Let's try. What is v? V is, that is v, is e exponent x. And what is du? Du is dx. Then that is dx. Then this is now simpler compared to this. This is not complicated compared to this. Therefore, what is the answer? Then the answer is this. That is all. If you are not sure, we know. You differentiate it. It must give you this back. Hopefully that makes sense. Any question thus far? Any question thus far? I saw another example there. I'm not sure it's an example, it's an exercise somewhere. Okay, let us just try and see whether indeed we are together. Can we use integration by parts here? Or which technique? Let me just open the question. Which technique will work here? Oberman? Wani? Which technique will work here? Sitole? Okay. Can integration by parts work here? Waiting for answers. Can integration by parts work here?
Yeah, I'm not quite sure, but I suspect so.
Yeah, maybe it will work, but it's going to be very difficult. You have to integrate by parts. You have to repeat it more than twice. You're going to repeat it more than twice. But once is x squared here, then this is standard. But once it becomes this, then it's integration by parts. But now, what if now you have got something like this? Something like this. Because we have said, generally, choose u as something that you can differentiate. Because once you say this is u, then you must differentiate. And dv be something that is standard to integrate. Because once you say this is dv, then the next step is it must now be what? You must now integrate that dv and get v. You see. But we said above all, if there is a factor that has got a finite derivative, once you differentiate it somewhere, it gives you a constant, then let that be u. You see. But now here, which one will be u? Which one has got a finite derivative? No. None here has got a finite derivative. Therefore, here, you can just choose anything to be u and anything to be dv. But not forgetting that from that dv, you must integrate. From that u, you must differentiate. Don't forget that. So let's try it. Let's say what? Let us say u is how much? Here you have a choice. Because there is no factor here that is finite. There is no factor here that has got a finite derivative. Therefore, here you can choose u as this one, or you can choose u as this one. So let's choose u as what? Let's say as sine x. Because I saw in your example, they've chosen u as e exponent x. I remember it. In the book, I saw that they've used the u as e exponent x. So therefore, let us approach it differently. You will just go and compare it with I'm not sure whether it was an exercise or whatever, but I saw it somewhere. Then from there, what? This is out. Is u. Is out. Then you still have what? E exponent x and dx. Therefore, dv, it must now be e exponent x dx. Then from u, then you differentiate, you get du dx, which is cos x. And here, you must now integrate and get this. And from here, what do you do? Then you write this. You multiply both sides by dx. Then you have got this. We have got this. Then what next now? Then this becomes e exponent x. Sine of x dx is equal to how much? Integral. We know this. This is u. Then we know this. This 2. What is this 2? This dv. Is good. And this, by that formula, this is uv minus v du. Then you then substitute. What is u? Is sine x. What is v? Then this becomes e exponent x sine of x minus what? Integral. But don't forget, this one, it must not be more complicated than the initial integrand. This must not be more complicated than the initial integrand. If yes, then you know that is a problem with your choice. So what is v? Is e exponent x. What is du? Is cos x dx. Then you pause and say, my initial integrand, it was this product. Now I'm have to integrate this. Then you compare them. Is this more complicated than this one? The answer is no. They're of the same degree. The answer is no. They're of the same degree. But this still needs integration by parts. Then you continue to integrate this by parts again.
Sorry to interrupt. I wanted to ask, can I?
Yes, Itole?
Yes, I wanted to ask. Sorry to interrupt.
Just increase the volume. I can't hear you properly.
Can you hear me now?
Yeah, again.
Can you hear me now?
Yeah, better now.
Okay, so my question is that I wanted to ask, since you relate use cos to sin x, and then obviously when we derive that sin x is going to be cos x, right?
That's correct.
Now on the other side, I can see that you actually derive the e to the power x, which is dv is equals to e to the power x, right?
Correct.
And then there on your right, I can't see properly. On your right, after you derive the dv is equals to e to the power x.
What? This step.
Yes. There I can see there.
This one.
Yes.
Then we said then. We have said let u be this and dv be this. Then from this you differentiate. And from this you integrate. This you differentiate, you get this. This you integrate, it will not be integrate both sides. The integral of the derivative of v, the integral and the derivative, these two processes, they cancel each other. Then you get v, you get the v back. The integral of e exponent x with respect to x, it will be e exponent x. Then from there.
Yes. I wanted to ask, will I be wrong if I derive that use cos to sin x and say the integral of sin x is equals to u is equals to cos x dx? Will I be correct if I put it in that way?
No, this is u. Then you must differentiate it. It's not a dv. It's not du. It's u. It's like y. Right. Then you must differentiate it. This one is dv. Then from this, because it's dv, meaning it has already been differentiated. Meaning you must now integrate it. It's like.
All right, I understand.
That's right.
Thank you.
Then once you, after this, then you go back to the original integral. Then you write it. Instead of sine x, we know sine x is u, then it's u. Instead of e exponent x dx. That is why I have this rate. Because we have said these two, the product, they can be swapped. You can even see this as what? They can be swapped. You can see this as sine x multiplied by e exponent x dx. So instead of sine x, now you have got u. Instead of this, is dv. That is by choice here. Then what is this? This is a formula. Just have to know it. What is this? Is this? And now from here, what next? You must now go back to x now. What is u? Is sine x. What is v? Is e exponent x. That is this. Minus the integral of. Then that is where we've said what? This new integrand, or this second integrand, it mustn't be more complicated than the initial one. Then that is where you pause and say, but now I was asked to integrate this product. I'm now faced with this one. Is this one now more complicated than this one? The answer is no, they are of the same degree. Therefore what? You are on the right path. So then what do you do now? It's just I don't have space now. What do you do now? You don't change, you don't swap, you don't change. You will still be what? You will still say, let u be what? Cos x. Because here we've chosen u as sine x. And what now? dv be e exponent x dx. The same story like here. What is du now? It will now be minus sine x dx. This side, v, it will be e exponent x. You see. But don't forget, this is minus this. This minus outside. Therefore, now this now, hopefully, I'm not crowding this that much. It will now be, again, what? u dv. Then when you substitute now, using this, what is u? Is cos x by what now? No. This by formula is uv minus v du. Then you substitute here. What is u? Is cos x. What is v? Then it will now be e exponent x cos x minus, what is v? V is e exponent x. What is du? Du is minus sine x dx. Then you then come and replace this by this. Replace this by this. Remember, they still did this one. Then what is this? This minus and minus, they will give you plus here. Hopefully it makes sense. Then we are now going to replace this part here by what? By e exponent x cos of x plus, don't forget, that is integral of e exponent x sine x dx. Then you pause and say, I was given this. I'm now integrating this now. Here it looks like we are going in circles now, but the good thing is what? This is minus now. When you remove brackets, this is going to be minus. When you remove brackets, because there's a minus here, this is going to be minus and this is going to be minus. You see. And what is the left side? The left side is this. It means the integral of e exponent x sine of x dx is equal to this. And the good thing is what? This is minus, this is plus. Then you take this. This and this are the same. They differ by signs. So therefore, if you take this one to this side, then it becomes 2 this. Hopefully it makes sense. If you take this one to this side, then it becomes 2 this. Therefore, this, it will now be 2 this equal to this is now gone. Then you can get rid of the 2 because it's a constant. Therefore, without the 2 here, it will now be half in brackets it is. then you can just say the see outside or simply see the inside. There's no problem. Then it will be this. Any question thus far? I think now we have got what? We had what? It's more than 2 hours. If there is no question, we can just stop here. And then next week, I'm not sure whether we have agreed on Saturday or Saturday, then we will proceed. Then I will just make sure that my laptop camera is fixed before that. Otherwise, then I will still use this external camera. It's just that I never thought that these cables, because this external camera, it came with its own cable. Then I never thought that the other can just simply use what? The charger cable to connect this. Me being born before technology. I left this in my office because I knew that this laptop has got a built-in camera. Now they say virus, what, the camera cannot work. I need to what virus. So, but now I was not aware that, oh, this external camera, it can still work with the charger cable after a long struggle. So you can just go and revise this, and then on Saturday or Sunday when we meet, then you can just ask any question relating to this. Then we are left with what? It's still a lot. Then it means the next thing, then next time we need to accelerate a bit, because we still have areas and volumes and linear algebra. We will simply look at one example from each. Any question before we call it a day? Do you have a question, Muthetwa?
No questions, sir. Thank you very much.
Any question before? Remember this. I have my cell phone there on my Twitter platform. Unless if you are not in my group, you can still ask Dr. Tamini to give you my cell phone number. Let me just give you my cell phone number right now. It's 082 if you have got a pen and something to write. 082 398 7601. You can just simply WhatsApp me your question. 082, because this is recorded, you can still get it from the recording. It's 082 398 7601. You can just simply ask me via WhatsApp. There's no problem. So thank you very much for my dear students for being patient. Thank you. Bye.
Thank you,
See
sir.
you.
Hope we meet again Saturday.
Yeah. If we agreed on Saturday, okay, no problem. They will remind us, ne? Okay. Thank you very much and bye. Enjoy the rest of what